Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 students who are preparing for the EQAO. It is based on a package of practice questions I handed out, and it's the last question in the package, question number 7, so video 7. And here's the question. It says, information about 3 relationships is given below. Circle the relationships that have the same rate of change. Justify your answer and include information about all 3 relationships. So obviously, if you simply circled a relationship, you're not going to get a lot of marks. You might randomly guess the right one, but we need to justify it by including information about all 3. So what is this a question about? Well, it's about rate of change. So we need to discuss and look at the rate of change of each of these 3 relationships. And what is rate of change? Well, rate of change is, we usually say slope. It's a measurement of how the graph changes vertically for every change horizontally. That's why we sometimes say that it's delta y over delta x, because it's how the vertical changes compared to how the horizontal changes. So we're really talking about slope. So we want to look at the slope of each of these relationships and then see which ones have the same slope. So the first relationship is given to me graphically. So how do I find the slope from a graph? Well, typically we talk about rise and run. So how much do I rise and how much do I run? And I can compare that using a fraction. So if I go from this point to this point, how much up do I have to go? Well, up is a measurement of vertical, so I'm thinking only for a minute about the y values, and I start here on the x-axis where y is 0, and I go up to this point, which is at 5. So I have to go up 5, and then how much do I run? And you can see clearly that I'm running to the right, because you always have to run to the right. And I start at -10, and I end up here, which is at the 0 measurement, so I run 10. So from this point to this point, the slope, the rise over the run, is rise 5 and run 10, which reduces to a half. And it's always a good idea to just keep this in mind, that the line from left to right is going up, which means it's positive, and my answer is positive. So I want to make sure I get that right. So here the slope is 1/2 or 0.5. So that's the rate of change for relationship 1. Let's talk about relationship 2. So relationship 2 is given to me as a standard form equation, and I need to find the slope. And the most common way of finding the slope is to rearrange the equation into slope-intercept form, because in slope-intercept form, that m is the slope. You'll notice I used m over here because that's slope. So I need to rearrange this standard equation into y equals mx plus b. And so what do? Well, so the y term stays on the left. So the y term is positive 6y. So I'm going to leave that on the left, but everything else is going to move away. So I don't need to put plus 6 because it's just going to be 6. 3x, well, that 3x was on the left, and I didn't want it on the left. I need it on the right. So how do I get rid of it on the left? Well, to get rid of positive 3x, you would do subtract 3x on both sides. And so that's where it shows up. So it looks like I took it and moved it, but the math is slightly more than that. But, we know this, right? But I have 3x on the left, and since I'm trying to isolate something else, it shows up as negative 3x on the right. This plus 1, I also need to remove that from the left. How do I remove plus 1? Well, to get rid of plus 1, we do minus 1. So there I've moved every term except for the y term to the other side. And again, I'm trying to get y equals, and now I have 6y equals. So how do I get y if I have 6 times y? Well, to get rid of multiply by 6, I need to divide by 6. And of course, if I divide on the left, I have to divide everything on the right as well. So what happens? So here I get 6 divided by 6 is 1. So I'm left with 1y, which is what I wanted. Here I have -3 divided by 6. Well, -3 divided by 6 is -1/2. And of course it was x, so that x is still there. and then I have minus 1 over 6. That doesn't reduce, it's still negative 1 over 6. So now I've rearranged it into y equals mx plus b form, and I can tell you what the slope is because the slope is right here. So the slope of this line is negative 1/2. So these two are not the same slope. One of them is positive and one of them is negative. So while they both change by 0.5, one of them changes in a positive sense and one changes negative. And we don't consider that to be the same rate of change because obviously if I gain 50 bucks, that's not the same as if I lose 50 bucks. Definitely. So let's look at the third relationship, and this is given to me in a table of values. So to find rate of change from a table of values, I will look at first differences. So how is x changing? So from negative 2 to 0, I added 2. From 0 to 2, I added 2. And here I added 2. So on this table, there is a constant change in x of positive 2. What's happening in y? So from negative 3 to negative 2, I need to add 1. Negative 3 plus 1 is negative 2. From negative 2 to negative 1, I add 1. From negative 1 to 0, I add 1. So there is a constant change in y values of positive 1. So for every change in 2 for x, there is a change by 1 in y. Slope, delta y over delta x, rise over run, is 1 over 2. So the slope of this line is 1 over 2. So you can see that the first relationship has a slope of 1 over 2. The third relationship has a slope of 1 over 3. So my answer would be to circle relationship 1 and 3. Did I justify my answer? Yes, I showed a bunch of math that showed I understood slope, and then I calculated slope in each case. Did I include information about all three graphs? Yes, I did math on all three graphs. So that's a good answer. The answer is that relationship 1 and 3 have the same rate of change. Relationship 2 cannot be considered the same because it's decreasing as opposed to increasing. All right, I hope that one was a good one. And keep studying, keep trying your best, keep getting confidence in math. Bye.